I'm Shravani and I'm from San Jose State University, pursuing my master's in software engineering, cohort in data science. I just wanted to present this presentation regarding the credit card fraud detection using Neural Network Auto Encoders. Firstly, we'll get to know how the credit card is frauded and also following with the types of credit card detections. So firstly, like credit card frauds are usually carried out with the intent to make quick financial gains of the hard earned money of unaware and otherwise technological inept victims. And also the major reasons for credit card frauds include like lack of adequate security and protocols and use of stolen credit cards and posing as the legitimate account holders and phishing sites posing as genuine transaction portals, etc. So basically when we are making the genuine transaction to the some other accounts, so we'll get to find some unwanted websites which make us to which come as like the ads. So unfortunately the people unknowingly click that websites and it takes the input of the user who are doing the transactions and it will redirect to the fraud one. So that's the major detection is going on nowadays. And also types of credit card frauds. So the three major credit card frauds, so that are the card related frauds and the merchant related frauds and the internet frauds. So firstly, credit card related frauds. So that is the application fraud happens when frauder replaces the actual one's application by detecting their personal details. So like we firstly discussed before, like when someone is doing transaction genuinely, so it redirects to the some other website, so which takes the all the inputs from the user and then it redirects to make the fraud transactions by detecting their all the input information from the customer. And also when the customer loses their debit or credit card, or else the customer feels that his card was simply lost, well the fraudster siphons money of the victim's account. So when like funnily we just forgot our credit card or debit card when we are when we are when we are drawing the money in the ATMs or else some other places like that. So we just simply think that we lost our card or else we forgotten our card, but it detects to the frauder, which it is a easier way to the frauder to catch up the money from our victim's account. And card not present, even though the technology is growing on nowadays, even the card is also not there, it is possible to transact without the actual physical possession of the card. And also fraudsters knowing the card details such as card number and expiry date and can still manage to commit frauds. So nowadays by using the just and card number or else by using the expiry date, even it makes easier for the fraudsters to get this into the card related fraud detection. And then merchant related frauds, so that is happening when the vendors pass on customers otherwise confidential data to fraudsters for monetary gains. So when we are doing the transactions, like unfortunately by using some third party apps like that, that confidential data is going into the fraudster's account. And then also they have massive plans like attract customers for some products like shopping carts and allow them to enter their personal details. Though through that they have plans to make the fraudulent transactions. Like nowadays we are seeing, when we are doing the shopping, like there are many fake websites are going on, like which inputs us to take the our complete details, like they're attracting us to the some shopping websites or else some offering sales like that. So they're taking our inputs and they're taking our all the details, and accordingly that they're also doing the they're also making the fraud detections. And then the major thing is the internet frauds. So somehow like same as the before we discussed merchant related frauds, this spyware tracks every keystroke made by the user and is later transmitted to a frauder who then uses these personal details for committing transactions related fraud. And also by using the cell phone camera scam, that this is the big scam going nowadays. Like when we are entering into the ATM or else when when we are doing any transaction at the somewhere places, so simply they're keeping the cell phone camera somewhere and they're taking all the details from us, and by that also the many frauds is going now. And then to come out of these, I have designed one of the proposed system architecture as we have seen in the screen below. So firstly, what I was doing is I'm just doing the normal transactions and also the frauded transactions, and that I'm just detecting the fraud input, non-fraud data input, and then I'm sending to the some of the algorithm, and through that I'm completely detecting the non-fraud data, like I'm using the model training. So from that, I'm just taking the two data sets. One is the test data set and the proposed processed data set. Sorry. So one is the processed data set and the other is a test transaction input I'm taking. So from the test transaction, again I'm pushing into the algorithm so that I'm getting the target one and then the output. So the target inputs, like what the unfrauded data is coming from the architecture, and the output includes what is the actual data we are seeing. So we no need to go into the output like it is the non-frauded transactions. So we should look after, I should look after the target data. So I should so I'm taking the target data in the form of some input table, like in the formation of table, like with the following columns giving like data type and the like their card number and what kind of the card is and what type of the bank card is and what type of transaction they have done and how much money they have transmitted, and also like etc etc. I have taken some of the data, and like from that I'm just predicting like in what way the exact transactions, like in what way the frauding is going on, that like that I'm just predicting by using the model interface. So this is my overall proposed system architecture I have taken for this project. And then coming to, well, like coming to the models, here I have taken two models like we have seen in the screen. The one is the encoder and the other is the decoder. So, well, what is the encoder? Like an encoder is an unsupervised learning technique for neutral networks that learns efficient data representation by training the network to ignore signal noise. So basically, an autoencoders can be used for image denoising or image compression, and in some cases, even generation of image data like that. Like by putting simply, the autoencoders are used to help reduce the noise in data. It helps me to get the like unfrauded data. It separates me the unfrauded data from my input. And coming to the decoder, the decode means to convert a coded message into intelligible language. So for suppose like the second person in the team playing Pictionary, like I just wanted to say a real time example for the decoder. Like the second person in the team playing Pictionary will convert the drawing into a word. So in the machine learning model, the role of the decoder will be convert the two-dimensional vector into the output sequence and the English sentence. Like it just make the customer more easier. Like the computer language is converted into the English, which makes the user more comfortable to understand. And the motive is to reconstruct the inputs back to a target value instead of predicting the new target values. So for example, we have seen in the overall proposed system architecture, like I just wanted to predict the only the target input. I just don't want to get back to the architecture, and I just don't want to predict the input again like we have seen the output here. My motto is to only predict the targeted value. Okay, and then coming back in an autoencoder network, the connections between the network, but no connections exist inside the layer itself. So the cost function defined and the used for the model is a simple mean squared error loss that can be represented as shown, like 1 by n summation of I equals to 1 yi minus yi whole square. So this is the graphical representation I have used here, and this setup ensures that our model evaluation would be much more strict and less prone to random errors. And then following with the experimental setup, so well, there's a major part for every project to implement their main motto. So I have taken the experimental setup. So I have set up my experimental like firstly I have followed through data collection and following with the data set wrangling and data visualization and analysis and data pre-processing. And here coming data pre-processing implies to three motions like one hot encoding and Z-code normalization and the data clipping. And coming to the data modeling, that is a major part where we can find their output by the graphical design. Means I have implemented by using the graphical design. I'll show you upcoming. Like first one, there is a data collection. Like data collection means just you are taking the complete data, like we have taken the complete data in the following. We are making some data set by using this some table representation like CSV files or else excel xsls files or else some excel files, etc. So I have taken in the form of CSV files and I have taken from input data sets from the Kaggle, where we can see the lot of websites. So we obtain a simulated credit card fraud detections like dataset Kaggle. And the dataset contains roughly like 6 million final transactions divided into 5 categories. So this data is some bit of long, like it is having some 6 million of financial transactions, and I have divided those into 5 categories like cash in, cash out, and debit, and the payment, and followed with the transfer. And then it runs slow when importing pandas. So see, when I'm using pandas in my project, like it is importing that the input is going very slow. So when I was importing pandas, so that's why I have used an alternate framework handlish called dask. Okay. And then coming to the dataset contains 8213 frauded transactions out of 6362630 transactions. So roughly I have taken 6 million financial transactions as I have said before. So from that I have seen 8213 frauded transactions is going, which is approximately represents 0.12%. So then coming to the my second setup, I have used a data set wrangling. See, I have taken the whole data set like which is having up to 6 million transactions. So from that I'm just picking up the frauded transactions, which is my aim to predict that. So with my aim is to predict the frauded transactions. So the only the frauded transactions I have wrangling, that means I'm picking up from the original data. So in order to train a powerful model, we need to ensure that the data set is clean and suitable for training. So it's the major part we need to set up firstly to implement our project. And then we achieve that first by understanding the data set by means of visualization and analysis, and then later on by building upon this knowledge, cleaning and pre-processing the data set is required. So we need to have the complete knowledge. Like firstly, the major parts is to for getting the data set to predict the what your aim is. The major parts you need to handle is the knowledge and the cleaning and the pre-processing data required. The knowledge means you need to have the clear and cut idea like what the data set you're taking and what's the main aim you're doing in your project. That's it. So the second thing is you need to cleaning up, like from the all this stuff you need to some clean up the data like which you just wanted to implement. And the third is pre-processing. You need to know the following steps for the pre-processing the data set. Okay, well, and then coming to the data visualization and analysis. So I have taken the 10 columns in our data set, transaction data set. Like the data set columns are a mixture of the string, numerical, and Boolean values. Like it might be the string, like numerical, and also the Boolean values, mm, like 0 1 0 1, which makes a 0 means it is the true transaction, 1 means some fraud is happening, and the column name and the data type and the description of the each column will be shown here. Like this is the actual data set I have taken, and the data set is highly imbalanced, and there is 8213 frauded transactions out of the 6 million transactions. This huge class imbalance would need to be addressed before any model can be trained. And this is the actual snapshot of the actual data set I have taken. Like as we have discussed, it is having the 10 columns like step, type, amount, name ORs, and old balance ORs, and new balance ORs, and the name their name data set, and also old balance data set and new balance data set is fraud or else is flagged fraud, etc. And this is the graphical representation like fraud versus unfraud. See, we are taking approximately 6 million of transaction data is having with us. So from that, non-fraud is okay, fine, non-fraud is fine. And as we have discussed before, there is approximately 8,000 frauded transactions we have seen seen in between the 6 million transactions. So this is the graphical representation I have taken and I have implemented. And fine, this is a major pre-processing, like this is a major step in my experimental setup called the data pre-processing. So well, the data pre-processing where we normalize and take other transactions based on the analysis we did in the previous step. In the stage we apply pre-processing steps such as z-code normalization and one hot encoding, etc. And well, firstly we'll know about the what is one hot encoding or z-code normalization and what is the data clipping. So one hot encoding is the most widespread approach is dealing with categorical data, and when the number of categories is especially small in number. And then coming to the z code normalization in particular helps to avoid outer layer issues that are present in case of minimum and the maximum normalization. And the data clipping, this is a major one in the data pre-processing. This technique is employed when there is a defined range between which the non-outlier values must lie. And this is the actual raw data set I have taken. I have used two data set. One is the raw data set and the one is the processed data set. And this is the actual snapshot of my raw data set. And this is a snapshot of pre-processed data set I have used. So we can see here the boolean and the numerical one and the strings is also there. Okay, so then fine. So this is my data modeling, and uh, by doing all my steps in this experimental setup, I have uh, drawn some like a graphical representation by using train data and also validation loss. So we can see the graph is simply goes slow, like it is predicting one by one, one by one, one by one so far. So that's it. And then conclusion, and then I want to just conclude my project and along with the future work. So like future work in upcoming, we just trying to implement the more easier ways to get out of the frauding detections. And also we just wanted to make the user, like we just wanted to make easier for them to know the difference between the actual websites and the frauded websites. And we just wanted to make more easier to them to get out of this frauded one. So this is my actual aim for my future work. And then conclusion is I just wanted to conclude this here. So like credit card fraud detection is very serious problem is going on nowadays, as we all know that. And I'm proposed an autoencoder model architecture for my problem. And in this future we'll try to train and evaluate a model on a larger dataset and improve the some efficiency of our model. And we'll also try to incorporate more interesting features such as the geographical location of the transactions, frequency of the transaction, etc. So by so I just wanted to add some interesting features like geographical location, like where the transaction is going on and at the what time and how much of the frequency the transaction is going on, etc. And you just go into my reference, like I have taken some research algorithms from this Philippine Chen and Fan. And also I have used my neural networks, so I have taken from the SAMIAS. And also I have published an article I can post in the description of this video, so you can go through that. It makes you more easier. In that I have also mentioned the algorithms, data sets and everything. So that's it, and thank you. And also I just wanted to say in this video, I have taken one collab, and I just imported some pandas, numpy, and some like following things you have seen here. And from these, I just taken from X dataset from the Kaggle. Mm, okay, fine. And then I have taken for the each data set I have taken. Okay, for the each column I have implemented the graphical representation. And the main major thing I have done is I have implemented the heat map. So here you can see the difference in the heat map, like You can see the color differentiation. So that's it. So I'll also post this link below this description. Well, thank you. And well, thank you for watching this video. Well.